If it is a square matrix of order 1 cross 1, then the element itself becomes the value of the determinant. Two determinants are equal. As in the case of two matrices are equal, two determinants can also be equal. For each row and column, there is a hidden sign, that is a position sign, which is important to find the sign. Suppose if you have more number of zeros in any row or columns, then you should use that particular column or row, because as I said, the simplification will become easier and faster. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are taking up with the new chapter, Determinants. So what do you mean by determinants? Determinants are related to the matrices, but determinants is nothing but the value given for a particular matrix, and it is defined only for the square matrices. So here in this session, we are going to study in detail about introduction to determinants, that is, what is determinant and how we are going to find the value of a determinant for a given square matrix. Now, let's see what is determinant. So, determinant of a square matrix Aij of order n is nothing but a value which is real or complex. Thus, for any square matrix, we can associate a number which is real or complex, and it is called the determinant of a square matrix A, and it is denoted by determinant A. It is written under the modulus symbol, but here we call it as determinant of A, or we write it as DET, that is det A, or symbolically we use the symbol delta to denote the value of the determinant of a square matrix A. Now, the important thing here, you have to note that the determinant is defined only for the square matrices, and determinant of a square matrix is always unique. So, for one particular square matrix, the value of the determinant is unique. So, therefore, it can also be defined as a function which is associated with every square matrices with a unique number. Hence, we can also call determinant as a function where the domain will be the set of all square matrices and the range will be any real values. Hence, the determinant is defined from the set of all square matrices denoted by M to K, which is a set of all real numbers. It may be real or complex also, and it is denoted in the form of a function M to K, where all the values of A is nothing but matrices. So, matrices belongs to the set of all square matrices, that is A belongs to M and the value delta belongs to K, where it may be real or complex. Hence, it is a function from M to K where f of A has delta. That is, for every matrices you have a real or complex value. Hence, f of A is called as the determinant of A, which is nothing but the delta. Hence, we can also determine the determinants as a function from the set of all square matrices to the set of real or complex numbers. Now, how to find a determinant for a given square matrix? Now, here the first one is determinant of a square matrix of order 1. So, for order 1 means a matrix contains only one single element, that is only one row and one column. Hence, the determinant, if it is denoted in the form of A is equal to some matrix A of order 1 cross 1. So, that means you have only one element in the square matrix. If A is a matrix with A as an element in it, then the determinant of A is always equal to A. Suppose A is a matrix of element containing only one element, that is 3, then determinant A, that is given by 3. Suppose B is a matrix containing element 0, then the determinant of a matrix B is 0. Like this, if it is a square matrix of order 1 cross 1, then the element itself becomes the value of the determinant. Next is determinant of an order 2. So, if there exists a square matrix whose elements is A1, B1, A to B2. So that is the order of 2 cross 2 matrix or order 2. It's a square matrix. Then the value of the determinant is written in this form. I have already told you should use a modulus symbol to write the value of the determinant. So here, so instead of square braces, here you are going to use a parallel line between this. You can write the elements here. So this is how we will determine the determinant A or det A, and it is given by A1, B1, A2, and it is equal to A1, B2, the product of A1, B2 minus A2, B1. So for all the 2 cross 2 square matrices, the value of the determinant is determined in this form only. That is A1, B2, change the sign, minus A2, B1. So for the second diagonal element, you have to change the sign and subtract. So for example, if I take the matrix A is equal to 1, 3, 2, 7. Then how we are going to find the determinant A? Determinant A is nothing but 1, 3, 2, 7. So first you have to multiply these two elements, that is 1 into 7, which is equal to 7, minus, then you have to multiply these two elements, that is 2 into 3, 6. So 7 minus 6, it is equal to 1. Hence we can associate a value for the given matrix, that is nothing but the determinant here. Now using this property, let us evaluate the given matrix here. So here we have to find the determinant value. So sometimes we can also denote it by delta or determinant A or det A. So these are all the symbols we are going to determine or denote the value of the determinant. Now here it is nothing but 2, 4, minus 1, 2. So according to the rule, it is 2 2s are 4 minus, then minus 1 into 4, minus 4. So which becomes 4 minus 4 is 4 plus 4, whose value is 8. So this is how we are going to find the value of the determinant. Now let us take few problems. Evaluate the given determinant. Here they have already given the matrix in the form of determinant. We are just supposed to find the value of the determinant. So let us find here. So multiply x square minus x plus 1 into x plus 1. So first we will multiply this, then minus x plus 1 into x minus 1. So use the brackets whenever binomials are used. So multiply here x square into x cube, x square plus x square, minus x into x minus x square, minus x plus 1 is minus x. Next it is plus x plus 1. Next here x plus 1, x minus 1 means it is x square minus 1 square. Outside you have minus, so that becomes minus x square plus 1. Now here clearly you can see plus x square minus x square get cancels, minus x plus x get cancels. So we have here x cube minus x square plus 1 plus 1 plus 2. So this is the value of the given determinant. Next one, cos theta minus sin theta, cos theta. So here cos theta into cos theta becomes cos square theta minus sin theta becomes minus sin square theta, which becomes cos square theta plus sin square theta. We know that cos square theta plus sin square theta value is 1. Hence the value of the given determinant is 1. Next question, find the value of x for which 3x, x1, 3, 2, 4, 1. So here two determinants are equal. As in the case of two matrices are equal, two determinants can also be equal. Now let us see this. 3 into 1 is 3, minus x into x is x square. Here 3 into 1 is 3, minus 4 to is 8. So from this we can clearly write x square is equal to 8, or we get x is equal to plus or minus root 8, or we can write x is equal to plus or minus 2 root 2. So this is the value of the given determinant. That is, the value of x is 2 root 2, plus or minus 2 root 2. Next one, find the value of x for which x 2, 8x is equal to 6, 2, 8, 6. So clearly from the given matrices, since here two elements are equal, directly we can write x is equal to 6. Or we can evaluate the value. So like this. So from this we get x square is equal to 36 or x is equal to plus or minus 6. But here clearly it is equal to 6. We can directly write x is equal to 6 here. Next one, find the value for which 2, 4, 5, 1 is equal to x, 3, 2x, 5. So let us find the determinant value first. 2 into 1, 2 minus 5 4s are 20. Next, x into 5 is 5x minus 2x into 3, which becomes 6x. So here you will get minus 18 is equal to minus x. Therefore, x is equal to 18. So this is the given value of x. Next, if a is equal to 1, 2, 4, 2, then show that determinant of 2a is equal to 4 into determinant a. So first, we need 2a. Here we have 2, here we have a. Let's write 2a. 2a means 2 1s are 2, 2 2s are 4, 2 4s are 8, 2 2s are 4. Now let us find the determinant of 2a. Determinant of 2a means determinant of 2, 4, 8, 4, which is 2 4s are 8 minus 8 4s are 32. So here 32 minus 8, which becomes minus 24. So let me take this as equation 1. Now let's see 4 into determinant a. So 4 into, what is the value of the determinant? 1, 2, 4, 2. Let's find out. 4 into 1 2s are 2 minus 4 2s are 8, which is 4 into minus 6, which is equal to minus 24. So let me take this as equation 2. Clearly from 1 and 2, I can say determinant of 2a is equal to 4 into determinant a. So next is determinant of order 3. So by how we find the value of the determinant of order 2, we can also find the value or the determinant for the matrices of order 3 cross 3. So here it contains 3 rows and 3 columns. Here we use the expansion method to find the value of determinant. Hence, there are 6 ways of expanding a determinant of order 3. Since there are 3 rows and 3 columns, so which we expand through any row or any column, it will give the same value, and that is known as expansion of a determinant along a row or a column. So if a matrix A has the elements A1, A2, A3. So I can also write A11, A12, A13. Next is A21, A22 here, A23. Next here A31, A32, A33. So this is how we denote the elements in a matrix according to the row and column, which we have already studied in the matrices. That is first row, first column element, first row, second column, first row, third column element. Similarly, second row, first column, second row, second, third row, first, third row, second, third row, third column element. That is, we have 3 rows and 3 columns. So we can take any row to the expansion or any column elements for the expansion. So this is also possible by notifying the exact sign how to expand the value of the determinant with any row or column. So here for each row and column there is a hidden sign, that is a position sign, which is important to find the sign. So for a matrix A of order 3, the sign is defined in the form of plus minus plus, minus plus minus, next plus minus plus. How this is given here? See here, the position of a sign is evaluated with this formula. So for the first position, that is first column, first row. That is I is nothing but row, j is nothing but column. So here both are 1 and 1. 1 plus 1 is 2. Minus 1 whole square is plus 1. So here it is nothing but plus 1. So symbolically we just write it as plus. And for the second column, first row element, I is 1, j is 2. So 1 plus 2 is 3. That is minus 1 whole cube, which we will get it as minus 1. Hence, the second element is written with the help of minus 1. So using the sign minus, we will expand it. Similarly, 1, 3 is 4, so it is positive. 2, 1 is 3, negative. 2, 2 is 4, positive. 2 plus 3 is 5, negative. So therefore, the sign is defined in this form. So thus, to expand the value of the determinant, every position has certain sign which has to be considered in evaluating or expanding the determinant. Thus, this is how we will take the sign, and hence the matrix has the sign or the determinant has the sign plus minus plus, minus plus minus, plus minus plus according to its position, number row as well as number column. Next is expansion of a determinant along a row or a column. So let us consider here. So this is a square matrix of order 3. Then determinant of a matrix is determined in this form, det A. So A1, A2, A3, B1, B2, B3, C1, C2, C3. Now let us expand it. How to expand it? Now I am showing you how to expand it through the first row. So first row, we are taking the elements of a first row. We will expand the element. So the sign is plus, minus, plus for the first row element. So I have to take A1. Now delete the row and column of the element A1 and write the remaining elements in the form of a determinant. That is, what are the remaining elements? B2, B3, C2, C3. This is how we are going to expand. So taking the first element, deleting the row and column of that element, write the remaining in the form of the determinant again. Now we'll take the second element. What is the sign of the second element? Minus. So we will write it as minus A2. Now delete the row containing A2 and column containing A2. So what are the elements we are? B1, B3, C1, C3. Write it in the form of determinant. B1, B3, C1, C3. Next is A3, that is plus A3. Again, by deleting the row and column, we get B1, B2, C1, C2. So this is how we will expand the value of the determinant using the first row elements only. So here we can evaluate the determinants, right? So if we evaluate this, B2, C3 minus C2, B3. Minus A2 outside, evaluated, B1, C3 minus C1, B3. Plus A3, B1, C2 minus C1, B2. So if you solve this with the help of numericals, again you will get a certain value. That is the value of the determinant for the given matrix. So thus, for any matrix here, if you take the expansion along the first row, so we will take A1 minus A2 and A3. We will delete the row number and column number or the row elements and column elements completely here, and we will take the remaining elements in the form of the determinant and we will expand it. Thus, on simplification, we will get the value of the determinant. Now, as I said, we can expand through any row or any column of a matrix. Now, previously I have shown you how to expand it using the first row element. Now, let me take the second row element. What is the sign in the second row element? Minus, plus, minus. This is important while expanding. So, how I can expand it? I can write it as minus B1. Delete the row and column containing B1. What are the remaining elements we have? A2, A3 and C2, C3. Next is plus B2. Now delete the column, row. What are the remaining elements we have? A1, A3, C1, C3. The last one is B3. Delete the column, delete the row, but minus B3 it is So minus B3, A1, A2, C1, C2. Again, by finding the value of the determinant here and on simplification, we will get the same value. So thus, you can expand the determinant with the help of any row or any column, which on simplification gives you the same value for any row as well as any column, which is a value of the determinant. Now here is a problem which I have taken. Now you can see clearly here. So one more hint I have to give here is, suppose if you have any row with zeros, then or any column with zeros, then expand the determinant using that particular row or that particular column, because it makes the simplification easier. Now let me show you the expansion of this determinant. So we have 1, 2, 4, minus 1, 3, 0, 4, 1, 0. Remember the sign always, that is plus minus plus, minus plus minus, plus minus plus. So this is the positions. Now let me expand the value of the determinant through last column. So last column means first element is plus minus plus. So let me take it as plus 4. So delete the row and column containing 4 and write remaining elements. That is, remaining elements are minus 1, 3, 4 into 1. Next is minus 0. So 0, second element is 0. Delete the row column. So we have 1, 2, 4, 1. And the last element is 0, plus 0. Delete the row column containing 0. Write the remaining elements in the determinants. 1, 2, minus 1, 3. Now we'll write here. Let us expand this determinant. Minus 1 into 1, minus 1, minus 4 3s are 12. Here we have minus. No need to expand this because outside we have 0. So it is minus 0. Here also it is plus 0. So 4 into minus 13. So here we have got minus 52. So this is the value of the determinant. So this is how we expanded using the last column. Let me show you expansion of any determinant with any other row. We will get the same value, that is minus 52. Now let us consider it. 1, 2, 4, minus 1, 3, 0, 4, 1, 0. Let me take the first row element. First row element is plus minus plus. So here it is plus 1. Delete the row, delete the column containing 1. Remaining elements are 3, 0, 1, 0. Next here we have minus 2 because second element is minus. Delete the row containing 2 and column containing. So we get minus 1, 0, 4, 0. Next here we have plus 4. Plus 4, delete the row, delete the column. Minus 1, 3, and here we have 4, 1. Let us expand this. 3 zeros is 0, minus 0. Minus 2, 0, minus 0. And here plus 4. Here we have minus 1, minus 12. So here it is 0. Here it is 0. And here it is 4 into minus 13, which is equal to minus 52. So the value of the determinant will remain same, but the expansion may differ. So you can use any row or any column. Suppose if you have more number of zeros in any row or columns, then you should use that particular column or row, because as I said, the simplification will become easier and faster. So next is, for easier calculation, we shall expand the determinant along the row or column which contains maximum number of zeros, which I have said you already. In general, if A is equal to K into B, suppose if A is a matrix which is equal to any scalar matrix with the other matrix B, then A and B are square matrices of order n, then determinant A can be written as K to the power n times determinant of B, where n can take the values 1, 2, 3. So therefore, suppose if matrix A is 2, 4, 6, 2. Okay, and matrix B is 1, 2, 3, 1. So this is matrix B. See clearly, if you multiply here 2, determinant A is 2 2s are 4, minus 6 4s are 24, which is equal to minus 20. And find determinant B. 1 1s are 1, minus 3 2s are 6, which is equal to minus 5. Now, from this relation, I can write matrix A can be written in the form of 2 times matrix B. That is, matrix B can be written as 2 times matrix. If you multiply 2 to matrix B, then I'll get matrix A. So thus this relation holds. Therefore, if A matrix is equal to some K into B, then determinant of a matrix A can be written as determinant B into K to the power n. Since it is equal to 2 here, determinant of A can be written as, so 2 to the power 2 into B. That is, what is B? Determinant B. So let's verify this. What is determinant A? Minus 20. What is 2 square? 4. 4 into minus 5 is minus 20. So therefore, whenever you have a matrices of this form, then the determinant A can be written in the form of K to the power n into determinant of B. Next question. Find the determinant of matrix A. So here already it is given in the form of determinant. So let us expand through any row or column. As usual, all numbers contains here, no 0 here. So let us expand using the first row only. So if you expand this, determinant A values, we know that for the first row it is plus minus plus. So 1 into. So delete the row column containing 1, write the elements. That is 1 into minus 9, minus 9, minus 4 into minus 3, minus 12. So you can directly evaluate the value of the 2 cross 2 matrices by deleting the row and column of particular element. Next is we have minus 1. Delete the row, delete the column. Here 1, but the sign is minus 1. That's why I have written minus 1 here. Delete the column, delete the row. What are the remaining elements? 2, minus 3, 5 and minus 9. Evaluate it. 2 into minus 9, minus 18, minus 5 into minus 3, minus 15. Next one is last plus, but here the value is minus 2. So delete the column, delete the row containing minus 2. What are the elements? 2, 1, 5, 4. So 2 4s are 8 minus 5 1s are 5. Now let us evaluate this. So 1 minus 9 plus 12. Next minus 1 minus 18 plus 15. And here minus 2, 3. So we get 3. 3 into 1, 3. Next here we have minus 18 plus 15 is minus 3. Minus 3 into minus 1 is plus 3. Next here we have minus 2 into 3, which is minus 6. So 3 plus 3, 6. 6 minus 6 is 0. So thus the value of the determinant is 0. So next, if A is equal to 1, 0, 1, 0, 1, 2, 0, 0, 4, then show that determinant of 3A is equal to 27 into determinant A. So first let us find out determinant of 3A. So determinant of 3A means multiply 3 to the given matrix and then find the determinant. So if you take 3A here, then 3A becomes 3, 0, 3, 0, 3, 6, 0, 0, 3 4s are 12. Now let us expand determinant of 3A. So just expanding this 3, 0, 3, 0, 3, 6, 0, 0, 12. I already said you when you have more number of zeros in any column or rows, expand with the help of that row or that particular column. Now I am going to expand the value of the determinant with the first column. So we know the sign plus minus plus here. So 3 into, delete the row and column, 12 3s are 36 minus 0 because 6 0 is 0. And next is minus 0, 0, delete the row, delete the column, and into anything is 0 again. Next is 0. Again plus 0. 0 into anything of the determinant, which is 0 again. Now let us evaluate it. 6 3s are 18, 3 3s are 9, 108 is the value. Next we have to check 27 into determinant A. So let's see. Determinant A is 1 0 1, 0 1 2, next 0 0 4. Let us expand this. 27 into. Again I am using the same first column because I have 2 zeros here. So 1 into. 1 4s are 4 minus 0. Again we will get minus 0 plus 0. So 1 4s are 4 we have. So we get 27 into 4. So which is 108. Thus determinant of 3A is nothing but 27 into determinant of A, and hence we have proved it. So these are all very simple questions from determinants which they may ask you for 1 mark question. So in this session we have learned how to expand a 2 cross 2, 3 cross 3 matrices to find the value of the determinant. We'll meet you in the next concept. Until then, keep watching, keep learning, keep exploring. Thank you.